Hello. In this demonstration, I will show how to do parameter grid search with cross-validation. Parameter grid search finds a model that best fits the data according to model hyperparameters. Cross-validation reduces the chance your model will be overfitted to a particular data set. The PySpark class CrossValidator is used for grid search with cross-validation. So let's look at grid search. Here's an example where I've got one model that has two hyperparameters. So for example, you could look at linear regression, and it has a number of parameters. We've got elastic net, and just for sake of argument, we could say max iteration. And we could put these two parameters in a grid search. A hyperparameter, that's what these are, hyperparameters for the linear regression model. And we can put it in a grid search. So the idea is you take one parameter, and let's assume my first parameter 1 has 3 different values. Then I take my other parameter 2, hyperparameter 2, it has 3 different values. And I do all combinations. So I do x of 2 with a, b, and c. And I do y of 2 with a, b, and c, and so forth. So it's 3 by 3, that is the count of each parameter, how many values it has. It's 3 in each, so 3 times 3 is 9. And you can put it in this format. It looks like a grid, and so you go through all the different enumerations of these combinations. So it's called parameter grid. And that's what we're going to use with our cross-validator class. We're going to specify these parameters and then run through the different models and try to find the model that best fits our data. That's the idea. So on the left, we have CrossValidator, which is a PySpark class, and we can give it a pipeline as an estimator. We give it an evaluator, like for regression, be R squared, and some parameters. It could be one parameter with a number of values or two parameters each with a few values. And then based on this, when you fit the CrossValidator and get some data, it's going to go through all the different parameters and return the best model, the one model and its associated parameters that best fit the data. In addition to that grid search, as we go along, we can use subsets of data called folds. And the idea is that rather than train our model on one data set, we're going to take a large data set, divide it up into subsets, and train it on some of these subsets and see how well it does. We're going to average them to get an idea of how our model performs over different data sets. So here's the idea of k-folds or cross-validation with k-folds. Take your k, let's say we've got 4 here for our k. Divide up our data into 4 subsets or 4 folds. And we'll take k minus 1, so that's going to be 3 is for training, and the last little bit, the last fold, is for testing. And then we repeat this for each fold such that as we go through, we train on all the data at some point and we test on all the data at some point. And the idea is we're going to take an average fit because the model may do well on, say, fold 1 and bad on fold 2 and really bad on fold 3 and good on fold 4. And we'll get an average of how well the model does. That'll be a metric of how well the model does. And the idea of grid search with cross-validation is to combine these two ideas. So the cross-validator is going to go ahead and compute the average evaluation metric for the model over the k different folds. So it's going to fit our parameterized models, our different models, over each of the k different folds, and then average that out to get an idea of how good the model is. And if we got multiple models, which we do when we're doing when we have parameterized models, then it's going to select out of all the models the one that has the best average over the k folds. It'll take that model and return it as being the best model among all the models. So that's how we use cross-validator. It's a mix of hyperparameters for models and then also folds to ensure that we don't train our model to just one data set, but we look across multiple data sets. So when we're doing grid search, think about these parameters to the overall effort. We've got the k folds, and that's the number of non-overlapping data subsets. Then we've got our models, and there's a couple ways to think about these models. Well, I can have one model like linear regression, and I could have one parameter like elastic net, and then 3 different values. So that's really 3 different models, or 1, 2, 3. I think I said here 2, but I meant to say 3. So there's 3, 1, 2, 3 different values, and that's going to be 3 different models. Another thing we could do is have one linear regression with no parameters and one decision tree model with no parameters, so each having no parameters. And so then in this case, I've got 2 models. So the model is really the kind of model in association with the number of parameterized values it can have. So k-folds times the number of models, that'll give us a total number of experiments. And this could be quite a few experiments. I could have maybe 5 models and 10 folds or something like that. So it ends up being quite a few. The idea, though, of PySpark, or Spark in general, is that I can run these in parallel because it's going to be running over a cluster. So how does this work? In the tuning part of the PySpark library, there's CrossValidator. And there we can specify, well, in this case, I specify an R formula followed by a linear regression. And that in total is my estimator. That's my pipeline. I'm going to take that pipeline and put it into CrossValidator and say, run this to fit the model against the data. I'll give it some sort of evaluator like R squared for regression models. And then comes the interesting part, my parameters. I'll specify some parameters, and I can specify a number of folds. So that's the k-folds and the parameters associated with one or more models. Once I've done that, I get this cross-validator. I can fit the cross-validator just like I fit a pipeline. I fit the cross-validator to some data, and then I get a result that's a fitted grid. And I can do some things with that. For example, I can ask it to give me the average metrics, and here I get the best model. So out of all the models, give me the model. It turns out all these models are pipelines. So I'll take the last element in this list. It's what R formula followed by linear regression. So that's going to be, the model here is going to be my linear regression, and then I can print out some information about it. So that's a little bit how I'm going to work with CrossValidator. As a rule, I can do multiple models and the parameters as well as multiple folds. And once I do that, I can put all of that in CrossValidator and run it. And then as an example here, I've got linear regression with, I think it has 1 parameter, and here's 3 different values of that parameter. Decision tree with 1 parameter and 2 different values. And generalized linear regression, 1 parameter, 2 different values. I can run all those in CrossValidator. I get my results, I just chart them out here, and then you can see that some of the models are not so good, but most of the rest of them are pretty much the same, so you could use any of those. So you can pick one of those and then go on to use that. So let's go ahead and do a demo with Databricks. Here I am in Databricks. I've got a notebook, and it has some data about USA housing. And the idea of our task here is to predict housing prices. So you can look at the data. It has a number of indicators here, income and house age and so forth, and we're going to predict price. And after cleaning up some column names, converting some columns to the appropriate type, dropping some stuff, we eventually get this USA housing variable that contains a Spark data frame. So do a few imports here of the appropriate things, and zoom in a little bit. And then let's go ahead and develop our estimator, which is going to be a pipeline of our formula, which is going to be all the columns minus price, predicting price. And the R formula then will be passed into the linear regression, which we're using to predict price. And this is just a standard way of using a pipeline in PySpark. And I'm going to take my pipeline and fit it to my training data. And I can see that I've got a fitted model, which is my pipeline. And I can take that pipeline and transform it against the, probably should have been training data here, but my test data, doesn't matter really for this example. And I can see that, well, a few things I can see about this. One is when the model transforms the data, I get a feature vector here, length 5, and that should be the 5 elements of my linear regression. So that's these columns, 1, 2, 3, 4, 5. Okay, so I get my 5 columns. That's this feature set is generated by our formula. There's my 5 columns. And then our formula also creates this labeled value based on what it's predicting. It's predicting price. So price is our labeled value. And so our formula just adds this new column called label. It's based on price. If you look, it's the same values. And then it goes on to when we do our transform is when we get our predictions, we predict the price. So you can see there's a little bit of difference between the actual price, the predicted price, but in any case, that's what our linear regression is doing. It's trying to predict that price. Okay, this is all standard, nothing new here. This is just, linear regression using PySpark with a pipeline. So, just some of the usual stuff. You can take the fitted model, grab the last element, which is the linear model, and print out the coefficients, intercept, and R-squared, and the rest. Okay, so let's see, the R-squared here is sort of important. It's 0.919. Now let's go ahead and see if we can improve on that, which is probably not likely, but let's give it a go. 0.9 is pretty good. But so we're going to use CrossValidator and Parameter Grid Builder. Everything here is identical once again. So we have this pipeline for an estimator. And now let's go on to something new. So let's define some parameters. And we're going to use Param Grid Builder to do so. And we're going to take the linear regression and set its elastic net param to be one of these in values here. It's a list of values. So we tell the Parameter Grid Builder to add a parameter for this parameter, the linear regression elastic net parameter. And here are the values to go through, to search through. Okay, and when you search, how do you know what is good? So you've got a regression evaluator, and you use a metric, and there's a number, but we're going to use, you can use root squared mean error. But here we have R-squared or R2 to determine what's a good model. And it looks in the predictions that's generated from the transform and label. Okay, so these are going to be, which is also equal to price. So this regression evaluator is what we're going to need to pass into our CrossValidator. So CrossValidator says, how are we going to estimate things? Well, we're going to use this pipeline. So our pipeline is going to be used. How are we going to evaluate, good and bad? We're going to use this evaluator. And what would you like me to search? And that's the parameters. So we give CrossValidator all this information, and then we tell it to fit against our training data, and then we get the fitted model. So once I have that fitted grid, I can do some things with it. Now, because I have a number of parameters, or one parameter with a number of values, I have essentially more than one model. Now, I know they're all just linear regression models, but they have different values of elastic net. So I've got 3 different values. Okay, so once I've fitted my CrossValidator to the data, I can then ask the fitted grid to get me the estimator parameter maps. And that gives me some of the information like how many models I have. There are 3 models. And what some of the model metrics are. So above we said the metric we're using is R-squared. And it's average metrics because it's assuming that you're going to do folds, even though we didn't do folds in this case. And the metric is, for the first model is 0.918 and so forth, second model, and they're all the same. So these 3 R-squareds correspond to the 3 values of elastic net that it ran. So 3 models for the 3 parameter values of our regression. Well, if we had different models here, then best model would pull out the best one. In fact, it does here, but essentially they're all the same. So it really doesn't make that much difference. But anyway, here's the best model out of that grid search. And then we can print out some information about it. You can see it's the R² is what we see above. Okay, so that's simply grid search. And next, we want to make sure that our model is not overfitted to a single data set. So if we got lots of data and big data, then we can split up our data into K sections or K folds, and then we'll run over various subsets of that data. And that's what this K folds is about. So now we add into our CrossValidator this extra parameter, which is the number of folds. And so I'm going to run the K fold being 3, and you can think about the number of runs or experiments it's going to do. And for every fold, it's going to run an experiment. And how many models do we have? In this case, we just have 1 model, linear regression. And it has 3 different parameter values, so it's going to run 3 times 3 times 1 is 9 different experiments. So we do that by saying CrossValidator, run against the pipeline we specified using the evaluator, which is R², the parameters, which is the 3 different values of elastic net, and give it 3 folds, which is what we had. And then once we have that, we can once again print out the metrics. And once again here, just note that even though I've got more folds, I still just have the 3 models. So I'm just printing out the 3 models, and I'm just getting the 3 metrics for those 3 models, 3 R²s, and it's all the same. And once again, I can pull out the best model and print out coefficients and all that, all the same. All right, just to make a note here that things are happening, notice that this 3 folds with our parameters took about 16.7 seconds. And later on, I'm going to run it. Here I run it with 6. And it's 29 seconds. So it may not seem like it's doing anything, but in fact, it is running 6 folds instead of 3. And it takes about 30 seconds instead of about 17 seconds. So it's taking a little bit longer. So same thing here. You can look at total number of experiments, folds times number of parameters, and you can see that's because there's more folds, it runs more experiments. But once again, we got the same elastic net doesn't seem to make much of a difference on this model. And there's some reasons for that, but this is just a demo. Okay, so that's pretty much the end of using CrossValidators commonly done. We have some estimator here. It's a pipeline. We have an evaluator, which is R². We have some parameters. I just used 1 parameter with 3 different values, but you could have other parameters if you had a model that, maybe decision tree or something had something else to look at for parameters, and the number of folds. All right, but now I want to add a little bit more to it, and that is not only do I want to do a parameterized model, meaning a model with different parameter values, I want to do different kinds of models. And so here's some other kinds of models that you can see for regression from PySpark library. There's a decision tree and generalized linear regression and so forth. Okay, so with those things, let's go ahead and use them in a pipeline in a grid search. So our formula is going to be the same as before. And now on to some new bits here. I've got a pipeline I'm going to define beforehand with stages as empty. And this is important that the stages are empty. So I'm going to refer to this below, but just want to point out that I've got a pipeline here. It's an empty, and then I'm going to put in real of the other pipelines in the parameter grid. It's sort of an interesting use of the parameter grid. All right, I'm going to think about my pipeline, and all my models are going to be this R formula followed by some sort of model. So it's going to be R formula by linear regression or by decision tree or by generalized linear regression. So just to make, in some cases, I'll have a very long base pipeline here. So this is a common idiom by which I specify such multiple models. In any case, I want to point out this is the starting or base pipeline that's going to be used below. And one last thing, I've got a parameter grid, and this one's just going to be an empty list, and I'm going to start to fill it up. I'm going to fill it up with all my different parameterized models, and that's what this plus equals is. I'm going to add to that list. So let's start with the first one here to see what's going on. I've got a parameter grid builder. So this is going to be a parameter in my CrossValidator. And what am I putting in it? This is a bit of a trick here, this base on. I'm going to start with this pipeline above, which is an empty pipeline, you recall. And I'm going to specify the stages which above were empty, but now I'm going to add to it this pipeline. I'm going to essentially replace it with this pipeline. This pipeline is the R formula and linear regression. And I could have also specified it here, but it's just a convenience for me that I use a named list based pipeline and add to it linear regression. Okay, so this is one of the models I'm going to run, the linear regression. And in this parameter grid area, I'm going to specify the parameters. So I'm going to specify a regularization parameter and give it 3 different values. Okay, and I'm going to add that to this growing grid, which I'm going to show in a moment how it gets, it's a list of pipelines that are parameterized. In any case, I repeat this pattern. So I've got a decision tree regressor. I use the parameter grid builder to specify a pipeline based on the pipeline above, which is empty. And I override it with this base pipeline in the decision tree regressor. And I add a parameter for this specific model, this pipeline here. The decision tree min instance will be 1 and then 5. Okay, and then just repeat this pattern one more time. You can do it as many as you want. And this time I'm going to use generalized linear regression. I base it on the empty pipeline above. And then this time it's the same pipeline, which is our formula followed by generalized linear regression. And I just specify one parameter here with 2 values. Once again, you could do more. All right, so after the end of all of this, I've built up this parameter grid, and it has multiple things here. Basically, they're pipelines that have parameterized pipelines. So if you scroll down here a little bit, you can see what this looks like. The parameter grid is indicated above is just a list, and then each one of these models is added to that list. It's added to pipeline. So you can see there's a parameter here where it's a pipeline, and there's the elements of the pipeline, including their associated parameters. And you go through, and there should be a pipeline for each one of these and their associated parameters. Okay, so I should have a few pipelines there. All right, now that I've got, and they're placed in the form of a parameter grid. All right, now I go on to what we did before. I have to have a way to evaluate all these different pipelines, all these different models. I want to figure out which one's the best. And the way I'm going to compare them is with this regression evaluator. I'm going to use the R squared metric, R2 metric. All right, so now I finally run this whole thing. I've got my CrossValidator. I've got a pipeline, and just, don't be too confused about this. This pipeline is my funny blank pipeline, which is up here. It says this pipeline here. So it's going to be a blank pipeline, but I'm going to use all of this stuff I built up here in this parameter grid. So here we are. I got my blank pipeline. I've got an evaluator, which is my R squared. And then my parameter grid has all of my models and their associated parameters. So it's basically parameterized pipelines. And then in addition to that, I can do my folds. I could remove this if I didn't want to do folds, but I'm going to go ahead and do folds. So now I have all of my models and also all the folds. So I do the usual. I go ahead and fit this essentially parameterized pipelines, which has multiple models and their parameters. And then I can do the usual stuff after that. I can get the estimator, find out how many models I have. I have 7 models. How does that work out? I have 3 models here, 2 and 2. that should be 7 models. Okay. Okay, so there's another typo there. I'm going to skip it. Okay, so once I have those, I fitted my grid to the data. I can print out the number of models and the average metrics. Remember, it's going to be average metrics because it runs the models on the folds, the subsets of data, the folds. So on average, the first model over the n folds, I think it was 3 folds, its R-squared was 0.918, and the next one was 0.918, and so forth. And you can see some are different. So these are the average metrics over the folds. So there's my 7 models. And just to print it out to look nice, I wrote a couple functions here that allow me to take my fitted grid and get out the metrics and the model names. And that's what these 2 functions do. And I can use those, the metrics and model names, to plot them. And I use a Seaborn bar plot here to plot those, as well as the metric here is R-squared. So that gives me my different models. And you can see that most of them are about the same, but some of them here, the decision tree is not so good. And so once I have that, I can also take my fitted grid and pull out the best model. And I can print out the details from that model. I can also take that best model and transform it, not against the training data, but against the test data to see how well it does. And I can then, for that test data, I can look at the R-squared for the test data, which is a little bit different. You can see 916 compared to the training data of 918. And then finally, I can do the usual plotting the actual prices versus the predicted prices to see how close a fit it is. So that demonstrates the use of CrossValidator for doing cross-validation with multiple folds, but in particular for running parameters, running hyperparameters for models, and running those different models over the cross-validation k-folds. So that's it. So I hope it works for you. Good luck.